Dear students, you are welcome in the Education Department at SHAHD Association. Our lesson today is Rules of Stability. Make sure to subscribe to our channel for more lessons and don't forget to activate the bell to stay notified.
Today, we have three objectives. We will define Octet Rule, we will define Duet Rule, and finally, we will write laws with symbol. As we saw in the Explore section, how can we balance the pans? By removing a ball from the left side or by adding a ball on the right side. That's what atoms do to become stable. They lose, gain, or share electrons. Today, our lesson is about the chemical stability. But before we start, let's revise what is the valence electrons. The valence electrons are the electrons that are found in the outer energy level or in the outer shell. All the inert gases or the noble gases that are found in the group 8 are stable by nature. That's because they have a saturated outer energy level or they have a saturated shell. For example, if we take the helium that has an electron configuration of K2, as you see in this electron configuration, the K shell has the maximum amount, which is 2 electrons. So we say that the K shell is saturated and the helium atom is stable. Let's do another example. The argon atom, which has an electron configuration of K2, L8, M8. The outer energy level is M, and it has the maximum amount. So we say that the M shell is saturated and the argon atom is stable. Let's now start by the rules of stability. The first one is the Octet Rule. The Octet Rule states that atoms with 8 electrons in their outer shell are stable. This applies for the L shell and the M shell. So atoms tend to combine in such way that each have 8 electrons in its valence shell. Atoms gain or lose electrons from the outer shell to become stable. Let's do an example on the Octet Rule. The magnesium atom, which have 12 electrons, it has electron configuration as this: K2, L8, M2. Magnesium has 2 electrons in its outer shell. We say that magnesium is in group 2. It is metal, so it tends to lose electrons. To satisfy Octet Rule, magnesium must lose 2 electrons to have 8 electrons in its outer shell, and it becomes stable. So the electron configuration becomes as this: K2, L8, because it lost 2 electrons. Now the valence is the number of electrons that it lost. So we say that valence is equal to 2. And the magnesium atom become an ion Mg2 plus because it lost 2 electrons. Let's do another example in the Octet Rule. Chlorine that has 17 electrons. It has electron configuration as this: K2, L8, and 7. Chlorine has 7 electrons in its outer shell, so it's in group 7. It is non-metal, it tends to gain electrons. To satisfy Octet Rule, chlorine must gain 1 electron to have 8 electrons in its outer shell and it becomes stable. The electron configuration becomes as this: K2, L8, M8. It gained 1 electron, so we say that the valence is 1 electron. And the chlorine becomes an ion, Cl-. Now we will move to the other rule, which is the Duet rule. This rule says that the lowest energy level, which is the K shell, of an atom can contain only 2 electrons. So atom tends to lose, gain, or share electrons to have 2 electrons in the K shell. Let's do an example. The hydrogen atom, it has an electron configuration as K1. So we say that hydrogen has 1 electron in its outer shell. It needs 1 electron to satisfy Duet rule and become stable. And the electron configuration becomes as this, K2. In this example, it has 1 electron left, so we write the valence as 1. Let's do another example. The beryllium atom, which has 4 electrons, it has electron configuration as K2, L2. We say that beryllium has 2 electrons in its outer shell. It loses 2 electrons to satisfy Duet rule and becomes stable, and the electron configuration becomes as K2. Now, because it lost 2 electrons, we write the valence as 2, and beryllium becomes an ion, Be2+. The final point in this lecture is the lowest dot symbol. Lowest dot symbol is the chemical element symbol having dots as much as the valence electrons. So in the magnesium atom, the valence electrons is 2 because the last energy level has 2 electrons. So we write the chemical symbol Mg, and we start by making dots clockwise or counterclockwise. 1, 2. The chlorine atom, it has 7 electrons in the last shell, so the valence electrons is 7. We write Cl, and we start making dots clockwise or counterclockwise. 1, 2, 3, 4, 5, 6, 7. And this is the lowest symbol of a chlorine. This is the end of our session today. If you have any questions on the worksheet, please don't hesitate to contact me.
Thanks for watching. If you like this lesson, make sure to subscribe to our channel for more, and don't forget to click the bell to get all updates.